where the astronomers will be. Sergio and Juan are both Chilean astronomers. No, Spanish. Sorry, Spanish from Spain, and Juan is a Chilean astronomer. Yes. Thank you for receiving us.
No problem.
Thank you very much. Wow, it's very impressive.
So this is where it all happens.
So welcome to the ALMA control room. From here, as he was saying, this is a real view of the telescope up there. And it is from here that we are basically operating the antennas. Actually, you can see two special things today. One is the fact that we are doing some testing and we are observing the sun. Not many telescopes can observe the sun, right? Because heat can basically melt the telescopes. But the ALMA antennas are designed so that they can observe the sun. So most of the radiation of the sun is dispersed so that heat doesn't concentrate. And when I said that they can melt, is that they can melt. There was a telescope in La Silla, a bit southern from here, which was called CEST. And they were doing some kind of building or refurbishing of the telescope. And they went, it was an antenna like this one, and they went for lens. And they put it like this up here. You know, they parked the telescope and they went for lens. But the problem is that here in Chile, the sun goes through the zenith. And then when they were going for lens, the sun went through the zenith, and the heat started to accumulate, and it basically melted this part here.
Oh, wow.
Okay, which is a secondary mirror. Okay, so basically, there are two things happening today. One is that we are observing the sun, and that's why you can see the shadow of this thing right through the hole. The antenna, basically, as any other telescope, is just a thing which is collecting light. We are just collecting light. This light reflects there, and then the light goes through that hole. There's a hole there, and then the receivers are down there. And there's another special thing today, and you can see there's a yellow thing there. That's the ALMA transporter. I don't know whether there's anyone.
No, there aren't.
So this is this big machine which is in charge of moving the antennas around. Okay. So today we are moving antennas. And well, I said that in that hole there's a receiver. So the basic difference with any other telescope, that normal telescope here that you might have heard before, is that ALMA is not operating in the optical. So basically it's not looking at what we see with our eyes. It's looking at millimeter wavelengths. So this is something which is invisible to us. But in order to show that there's light which is invisible to us, okay? If you take your mobile phone, right, and then you put this remote control. If you press in the button, you see nothing. But if you put it in front of your camera, you see a small light blinking, right? Mm-hmm. That's infrared. Our eyes are not sensitive to infrared, but the camera here it is. Okay. And the same thing. ALMA is observing a light which is a slightly lower frequency than this frequency is there. And another difference is that compared to other telescopes, I mean, astronomy wanted to build larger and larger and larger and larger telescopes. But it comes a point in which it's impossible to build larger telescopes. Ideally, we would like to have a telescope of kilometers in size. But that's impossible mechanically to build an antenna of kilometer size. And so the solution, which actually won a Nobel Prize, was interferometry. And this is having small telescopes, and then you connect them together, you measure the signal between every pair of antennas, and you basically synthesize a large telescope. And that's how ALMA works. ALMA
interpolate or no? It's not interpolating, but it's because it's not making assumptions of the information between the gaps.
No, the gaps produce artifacts. So basically, the images that we produce are not perfect, and that's actually the reason why we move the antennas, because ALMA can extend all the way to 15 kilometers. Okay, with those, when we are at those distances, we have the finest detailed images. And then the question is, okay, if when you are so extended, you have the finest images,